Okay, so the three exercises on the joint probability content that we've covered so far. The first one is to calculate the marginal probability of Y, the star rating, in the fast food example that we already worked through earlier, where we were calculating the marginal probability of X. The second exercise is what is the joint probability of a card that you draw from a deck, a standard deck, having the type of being a face card and the color black. And then finally, drawing cards from a deck without replacement, what is the conditional probability that the second card that you pull from a deck is a face card, given that the first card that you pulled from a deck is a face card? Okay, so for our first exercise, we are calculating the marginal probabilities for our star ratings now. So we simply sum up across the rows. So the same denominator is here for this exercise as we had when we were calculating the marginal probabilities for X. So we still have 76 total ratings of our fast food. And so that's our denominator here. And then our numerator is simply the sum of each column. So there are 13 ratings that are a 1-star rating, 12 that are a 2-star rating, 34 that are a 3-star rating, and 4 that are a 4-star rating. So this is our margin now down here at the bottom of the page. And we could convert these into probabilities out of 1, a little bit easier to understand. So for example, there's a 0.45 probability that a star rating across any of our fast food items is going to be 0.45. So about a 45% chance of getting a 3-star rating. The solution to exercise 2 is relatively straightforward, assuming you're familiar with everything that's going on in a deck of cards. So there are 3 face cards in a deck. There's the Jack, the Queen, and the King. So there's 3 face cards per suit. We have 4 suits. 2 of those suits are black, 2 of those suits are red. So if we're looking for the probability that a card is both a face card and black, well, there's only 2 suits that are black, spades and clubs. So we have a Jack, a Queen, and a King of spades, and a Jack and a Queen and a King of clubs. So that gives us a total of 6 cards out of the standard 52 cards in a standard deck. And so that comes out to a probability of about 0.115. Okay, and for our third exercise, we want to calculate the probability that we draw a face card given that we drew a face card already. So we're drawing cards without replacement, remember that. So in order to calculate that conditional probability, first we need the joint probability. So we're going to need the probability that we draw a face on the first card as well as the second card. And the probability of drawing a face card, we know that there's 12 of them in the deck, right? So this kind of follows from the last question where there's 3 face cards per suit, Jack, Queen, King, and there's 4 suits. So that's a total of 12 cards from the 52 card deck on the first draw. But if we drew a face card on the first draw, then on the second draw, there's only 11 face cards left from the 51 in the deck. So the joint probability is given by this product here, and that's 132 over 2652, which simplifies to 11 out of 221 odds. So now that we have our joint probability, we can calculate our conditional probability. So the formula that we've worked through states that the conditional probability is equal to the joint probability of these 2 conditions, which is here, 11 out of 221, divided by the probability of the initial event, of the first event that has to have happened in order for us to do this conditional probability. And the probability of that first event, as we saw up here, was 12 in 52. And so this comes out to, once we do all of this division, comes out to about a 22% chance that we'll draw a face card on our second draw, given that we drew a face card on the first draw.